This is the third screencast in a multi-part series on creating the Simply Settings Rails plugin. Today we'll be adding hash behavior like fetch and using bracket methods. We'll be adding a method to list the available settings, and we'll be adding behavior to serialize and deserialize setting values. Alright, let's get started. The first thing that I want to tackle is a bit of refactoring. After the last screencast, I left the gem in a bit of a mess. What I don't like are these dependencies on active record sprinkled throughout, mainly here in the set method and also delete. And then method missing is just a bit messy. I don't like how we're reassigning method name and chomping the equal sign off. And I think we can clean that up a bit. So let's start with our delete method and move this active record dependency out. I'm going to define a new private method called remove, which will pass our record to. And we'll use the same implementation just to move that out. We'll later be moving all of these active record dependencies into their own file. Okay, so now let's move on to updating set. Along with this active record dependency, I also just think the method looks a little bit messy. Can probably clean this up. So let's start with our first clause here. If the value is nil, then we want to delete a setting. So let's return delete setting if value is nil. Then our second clause, if our record is present, then we want to update the record with the new value. So let's return update record, update setting value if exists setting. And then our third case is that we want to create a record if it doesn't already exist. So let's return insert setting value. Okay, so now we just need to define our update and insert methods. Can do that now. Update setting value, and we will look up our record and set its value to the new value and save it. Now for insert, we just want to copy this record.create line. Great, now we should be able to get rid of all of that code there. And I think that looks quite a bit cleaner. Let's run our tests, make sure everything's still passing. Everything looks great. That's one of the benefits of, well, that's the big benefit of test driving this gem here. We have pretty good coverage on getting and setting and deletion, so we can refactor with some confidence and run our tests as we make changes and be fairly confident that we didn't break anything. Alright, let's take a look at method missing, clean this up a bit. I'm just going to start by removing this chomp that I don't like and also this reassignment. And we will use a regex to do some pattern matching here and check if we match the pattern of anything followed by an equal sign. And then we can, anything in these parens here will get assigned to our $1, which we can use. And that looks quite a bit cleaner. Let's run our tests. Fantastic. Okay, so I was playing around with the gem in Rails console, and another thing that I didn't really like is just how verbose using simply settings is at the moment. I've decided against using a class and mixing in singleton. I think instead it'd be a lot more concise just to use a module. So what I'm going to do is get rid of this here, and instead of using class settings and including the singleton module, we'll just have a module that extends itself so that all of these instance methods are then added as module methods. We have an extra end here. And I'll just fix the indentation. Alright, let's run our tests. Great, everything's still working. Okay, things are looking pretty clean now. Let's isolate all this active record stuff into its own file. Make things a bit cleaner. So under Simply Settings, we're going to create a new folder called ORM. Inside of ORM, we'll create a new file called active record. And I'm going to copy this code here. And we'll stick everything in here that has an active record dependency. Let's move that there. And everything else will go into a different file that we will create. Okay, so we have all of our active record stuff isolated here. All of this is private. Let's create another file called core. In this core file, this is where we'll keep our API and our main private methods. So we'll get rid of all of this active record stuff. Now we need to update our Simply Settings RB file to require these files. Great, alright, let's run our tests, make sure everything's still wired up properly. Great. Okay, so we're going to close our directory tree here and take a look at the next set of tests. The next bit of tests have to do with the fetch method that we'll be adding so that Simply Settings can behave similar to a hash. Since we're going to have at least 4 different bits of behavior that are going to work like a hash, we'll create a new file. We'll call it hashable. And I'm just going to copy this and use its skeleton. Okay. Oh, we need to require this file. Just run our test, make sure everything's wired up. Great. Okay, so our first test inside of this fetching context is fetch returns a value if defined. So let's write our test setup. We will add a setting hello and assign it to world. When we call fetch and pass in hello, we expect this to equal world. All right. So fetch will take a setting and a block, and we'll just run our tests now, show that things are failing. So we expected to get world and got nil. So in order to make this test pass, what we need to do is just call get and pass our setting. Let's rerun our tests. Great. So that test is now passing. Let's move on to the next one. It defines and returns default value if undefined. That's a bit confusing. Let me rewrite that. What we actually want is if it assigns the default value if the setting is not found. Okay, so if we call settings.fetch hello, we pass world in a block, then we expect when we call settings.hello that we'll get world. Let's run our test. All right, so we expected world and we got nil because we're not yet handling the case where the setting is not defined. So what we need to do is we'll store off this the value we get from get, and we're going to return the value unless the value is nil. Otherwise, get the value from our block if one is given. Then we'll call set, pass our new value, and return our value. Okay, so let's run our tests. Great. Now fetch is implemented. We can move on to bracket access. So let's take a look at the first test. It sets a value with bracket equals. So what we're saying is if we use bracket notation here and say hello is equal to world, then we expect settings.hello to equal world. So if we run this, fails. So let's define our bracket equals method. So bracket equals takes a setting and a value, and all it does is call get. Call set. Setting value. We run our tests. Should be passing. Great. Move on to just regular bracket method. So what we expect to happen here is if we define a setting hello world, we expect that when we use the bracket notation, pass hello to get back world. Alright, tests are failing. So bracket method just accepts a setting, and it's as simple, it's even simpler than our bracket equals method. We just call get with our setting. Alright, so we have a failure. So get undefined local variable or method. I just misspelled settings here. And I did it here too. Great, so we've implemented our hashable. Let's go back to our core class. We just have one method that we're going to add for listing settings. This seems like core behavior. So let's add it here. We'll just have a setting. Well, actually, let's define what we expect to happen in our test. Okay, so it lists defined settings in ascending alpha order. So if we define a setting A, let's start with B, setting C, settings A, then we expect when we call settings.list to get an array A, B, C. Alright, let's run our tests. We fail because we expected to get ABC and we got nothing. Alright, so let's write our settings method. Okay, so in order to not depend on active record behavior, I'm going to have to call a private method inside of our active record file. We will call it list settings in order. And we can use our record dot order setting dot pluck setting list settings in order. Alright, our test is still failing. Let's take a closer. Oh, I called it settings.list. It's called settings. Great. Everything is passing now. Okay, so now we're going to move on to our test for serializing and deserializing objects. Our first test here, we expect that when we assign a Boolean, we get a Boolean back. So let's write this test. If we define a setting is true and assign it to true, then we expect when is true is called that the result we get is the value true. If we run our tests, this should fail because by default there's no serialization going on. So true is going to, in the insert statement, will get converted to just the first character T, and that's what will be stored, so that's what we'll get out. In order to make this work, we can use a class method that Active Record gives us called serialize, and we'll tell it to serialize our value column, and we want to use the JSON serializer. So now if we run our tests again, that test passes. Great. So let's move on to, if we assign an array, then we expect to get an array back. And this is the same sort of test. We'll define a setting isArray, and we'll assign it to 1, 2, 3. And we expect that settings.isArray to equal the array 1, 2, 3. Okay, fantastic. That passed. Now let's move on to hashes. If we assign a hash, we expect to get a hash back. So settings.isHash, and create a hash with the key hello and value world. And we expect that settings.isHash, when we use bracket notation and pass the symbol hello, that we will get world. And run our tests. Okay, so this test failed. The reason that this test is failing is that JSON, when it serializes to the database, is going to convert our hash, which we created with a symbol, into JSON, which will have a string key. And then when it's deserialized to a hash, the key will be created as a string. So in order to make symbols work, what we need to do is we can write our own serializer, create a class called JSON with different access for hashes. And we need two class methods, self.load for deserialization, and self.dump for serialization. And we'll just wrap the JSON module and pass load, or pass a string to load, and pass our object to dump. Now, if we swap out our serializer here, we're in the same position that we were in before. The test should fail in the exact same way. And it does. So what we want to do is, when we call JSON load, we want to store that object that we get back off, and we want to pass it to hash with indifferent access if the object that we're working with is a hash. So if we run our tests again, I think we'll be in better shape. Let's see. Okay, so got a bunch of failing tests now. Maybe because I'm not returning an object at the end. Yep. Okay, fantastic. Great. So let's move on to, it creates getters with question marks for Boolean values. So what we're saying is, if we define a setting is true and set it equal to true, then we should be able to access this setting with an is true question mark and expect this to equal true. So if we run that, it should fail. So in order to implement settings with question marks for Boolean values, we need to take a look at our get method, and what we want to do is reassign our setting and call toString on it because it's a symbol, and just chomp the question mark off the end so that when it does the lookup, it will be looking up with the original setting name. Alright, so let's run our test, and everything passes. We have no more pending tests, so that will wrap it up for this screencast. Next time we will go through and add some caching with Rails.cache, and also define methods for all of these dynamic methods on the fly so that if they're called a second time, it won't have to go through method missing, which will be much faster.